Hi everyone, this is the second video for protein synthesis and it will be covering the process of translation. We'll be using diagrams to help model the process to make it a little easier for you to visualize. So our mature mRNA has just left the nucleus and gone out into the cytoplasm where it has been able to find a ribosome. Now a ribosome is actually made out of two globular pieces of RNA, a large subunit on the top and a small subunit on the bottom. These two pieces are going to clamp down on the mRNA kind of like a hamburger bun. The mRNA aligns itself using the cap and then slides down until it finds a 3-base code called an initiation codon. The mRNA is read in 3 base groups called codons. This is the first one. It is followed by a second codon, a third codon, a fourth codon, a fifth codon, and probably many more. This section here is non-coding DNA and will be ignored. So essentially what's happened here is we've brought together two different kinds of RNA, our mRNA, which is carrying the code, and the rRNA, which is simply holding the mRNA in place. Once the mRNA is sitting on the ribosome, it is now time to bring in the building blocks for making the protein, which is why we have the code there in the first place. Floating around the cytoplasm, we have tRNA. tRNA are transfer RNA. Their job is to pick up amino acids that are floating around in the cytoplasm, which we can see here. Each one of them is responsible for picking up a different kind. And the type that they're carrying is indicated down here at the bottom in their 3-base code, which is referred to as an anticodon. Now, that anticodon is designed to match with, in the same kind of pairing codes, the codons that are on the mRNA. So on this diagram, you can see that one of the tRNAs has matched its anticodon to the codon on the mRNA. The tRNA is carrying its specific amino acid, and that is how the mRNA begins to be translated. Once the first tRNA is in place with its amino acid, a second tRNA comes down and matches its anticodon with the second codon on the mRNA. Now it brings with it its amino acid. And when these two amino acids are close enough, they start to form an attraction and begin to form what is known as a peptide bond. Now, this peptide bond is a specific type of covalent bond, so it's very strong and it's going to hold those two amino acids together. Once that happens, this bond right here on the first tRNA kind of dissolves away or is broken away, and the ribosome begins to shift over. Now, as it does that, this tRNA becomes less stable and begins to move out, leaving its amino acid bonded to the amino acid on the second tRNA. We can see this very clearly in this diagram. You can see that this tRNA is moving its way out and then no longer has an amino acid attached to it, but the second tRNA now has two amino acids attached together. This is the beginning of a polypeptide chain. Now we have our next codon, which is going to match with the anticodon of another tRNA, which is bringing with it another amino acid. These two amino acids start forming an attraction. As that happens, a peptide bond begins forming. The ribosome is going to shift over. This tRNA will begin to release its hold on the mRNA, and the bond between it and the small polypeptide chain is going to dissolve. Another tRNA will come down and link with whatever the next codon is. It will bring its amino acid, and it is going to continue codon after codon until it reaches what is known as a termination or stop codon. At that point, we're going to have an extensive polypeptide chain coming off of the tRNA. Now, that polypeptide chain, once the termination code is reached, is going to release itself, and its primary structure is going to fold or spiral into its secondary structure, and then glob into its tertiary structure. Once it has its tertiary structure, then it has enough of a shape that it's going to be able to perform whatever function it is supposed to serve.